Greetings, everyone. My name is Xin Tan, and I am an assistant professor at Beihang University. It's my pleasure to welcome you to my talk today. I'm honored to present this joint work, which was accomplished in a collaboration with Yiran Chen, Haohua Wu, and Li Zhang from Beihang University, as well as Minghui Zhou from Peking University. Newcomers are very critical for open source projects because they are very important for the continuous development and the success of the open source projects. Newcomers also eagerly participate in open source projects. However, newcomers face various barriers when they contribute to the open source projects for their first time. So it's necessary to provide support for newcomers, especially for their first steps. Many studies are devoted to help newcomers for their onboarding. Some researchers focus on understanding their contribution motivation, including intrinsic motivations and extrinsic motivations. And some studies focus on the barriers of newcomers, including technical and non-technical barriers. And there are also some researchers focus on theories and strategies helping newcomers. Among different strategies, researchers find that task recommendation is very important. This idea is also applied in practice. GitHub encourages open source projects to use the labels such as Gold First Issue to recommend suitable tasks for newcomers. A lot of studies focus on Gold First issues, including our research group. In FOSE-AI 2020, we conducted a first look at Gold First issues on GitHub, and 2 years later, in ICSE, based on our previous results, we built an automatic tools to recommend Gold First issues for newcomers. However, it's still unclear whether just recommending Gold First issues is enough and how significant is mentoring for newcomers. Thus, we propose 4 research questions. We take 4 different perspectives, including expert involvement, mentorship structure, the discussed topics between experts and newcomers. And the last research question focuses on the relationship between experts' participation and the newcomers' onboarding. To answer the above questions, we focus on the GitHub projects, and we use the torrent data set. We select the projects that have more than 1 Gold First issues, and we choose the top 1% projects with the most Gold First issues, and only keep the closed Gold First issues as our final data set. So we analyzed 947 projects and more than 68,000 Gold First issues. Our first research question aims to know the extent that experts involved in the resolution of Gold First issues. To answer this question, we define 3 types of different rules. First is the expert. We refer to previous studies and define expert as a developer who was among the top 20% of contributions in the year before she or he made the commit. Newcomers represent a developer's number of commits contribute to the project is less than 3. If a developer is neither a newcomer nor an expert, we consider them as general developers. This chart shows the participants of the different roles during the Gold First issue resolution process. We can see that the category of newcomers and experts both commented takes the most proportion, around more than 43%. So we can conclude that in total, nearly 70% of Gold First issues have expert participation. It can index that experts usually participate in the Gold First issue resolution process. We are also very curious about the efforts of experts in this process. So we calculate the efforts from two aspects. The first is the number of comments, and the second is the number of commenters. These two aspects are all focused on the experts. We can conclude that the effort of experts is limited. Each Gold First issue usually has one expert participating, and this expert typically makes two comments. The last perspective to answer the first research question is the response time, because we are curious about how quickly that an expert responds to a newcomer's comment. So we define response time as a time interval between newcomer's first comment time and expert first comment time. We find that the first expert comment is usually received within 8.5 hours of the newcomer's first comment. The second research question aims to know the structure of the mentorship. We visualize the relationship between newcomers and experts. This slide shows several examples of these four different mentorship structures we identified. In this network, a node represents a newcomer or an expert, and an edge represents that a newcomer and expert have left the comments on the same issues. By adopting open card sorting, we find there are four types of mentorship structures. We find that collaborative mentoring takes the most part, followed by centralized mentoring, distributed mentoring, and decentralized mentoring. To investigate the differences between these four different types of mentorship structures, we take two perspectives. The first perspective is network characteristics. By referring to network theory, we calculate several metrics, such as the ratio of experts, the degree centrality, and the betweenness centrality. Another perspective is project characteristics, because we want to know the relationship between the project characteristics and these four types of mentorship structures. We calculate several metrics related to projects. For example, the number of authors, the number of commits, and the number of issues. These two charts shows the distribution of these different metrics. We find that these four types differ in topology and project characteristics. For example, communities belong to centralized mentoring have higher closeness centrality, but they are usually smaller, younger, and less popular. Our third research question is to know the discussed topics during the Gold First issue resolution process between newcomers and experts. So we want to obtain the rich topics, so we focus on the highly discussed topics. And we also select the Gold First issues with both newcomers and experts participating. Eventually, we obtained 2,600 Gold First issues. To understand what they talk about, we adopt a thematic analysis of issue comments and focus on the dialogues between newcomers and experts. To complement the above results and evaluate the frequency and difficulty of these topics, we conduct email survey with newcomers and experts. Finally, we received 43 responses, including 11 responses from newcomers and 32 responses from experts. This chart shows the discussed topics and the attitudes of newcomers and experts. We can see that newcomers face various challenges, such as understanding, implementation, testing, and management communication. To help newcomers solve these challenges, experts provide various mentoring. For example, the community regulations, task recommendations, and implementation feedback. If you are interested in these challenges and mentoring behaviors, I recommend you to read our paper. Through the above research questions, we know the involvement of experts, the mentorship structure, and discuss the topics, but we are still unclear the relationship between experts' participation and newcomers' onboarding. So we propose two sub-research questions. The first one is mentoring related to why the gold first issues can be solved by newcomers? And second one, we focus on newcomers' long-term contribution. So we ask, is mentoring related to why the newcomers continue to contribute? We construct two generalized layer models to answer the two sub-research questions. These two tables show the regression results. We conclude that newcomers will have more chances to solve the gold first issue if they leave more comments on the gold first issue. And the gold first issue is from more popular projects, and all experts are involved in the resolution process. And we also find that newcomers with stronger skills and a stronger willingness are more likely to make long-term contributions. Our work has rich implications. Newcomers are the direct beneficiaries of our study. Our findings can promote mentoring process, so in turn reduce the barriers to newcomers onboarding. For experts, we suggest them to plan ahead and provide more targeted guidance on the challenges we identified in the third research questions. And also they can adopt automatic tools. Another suggestion is reducing cognitive differences between newcomers and experts. For open source communities, the centralized mentoring communities may have a high risk of single point of failure because in this type of communities, there is only one expert who is responsible for the mentoring of newcomers. So it is necessary to have a backup mentor for newcomers. Also, the open source communities should provide a friendly and inclusive atmosphere to encourage newcomers. For researchers, our study proposed several ways for future research. For example, researchers can design classification algorithm of the mentorship structures that we identified and introduce other factors to refine our model, design automatic tools to facilitate the mentoring process based on the challenges. Before finishing my talk, I would like to give a brief summary. We conduct the first detailed analysis of the historical data on daily mentoring behavior of newcomers onboarding in open source communities. We take 4 perspectives, including the involvement of experts, the mentorship structure, discuss the topics among experts and newcomers, and the relationship between experts' participation and newcomers onboarding. Newcomer onboarding is a very challenging but important issue for open source communities. Our work can help people better understand the significance of the mentoring in this process. Thank you for your listening. I'm happy to answer your question, and if you have further questions, please feel free to contact our authors.
Hello, everyone. My name is Madeline Endries, and I'm a PhD student at the University of Michigan. And today I'm going to be talking about our paper, From Organizations to Individuals, Psychoactive Substance Use by Professional Programmers. And before we dive into detail, I want to introduce my collaborators, including the fantastic Dr. Brittany Johnson right there. But also, I would really like to shout out our first author, Kaya, who is also here in the audience. She was an undergraduate when she was working on this research, is starting her PhD next year, and she has a poster, a digital poster that she made that you should all go check out. So she's pretty awesome. Okay. So, and as Brittany also mentioned, I'm going to be on the job market starting in fall 2023, looking for research-focused faculty positions in 2024. So reach out to me. Just let me know. Cool. Okay, to start, I'm going to talk about something that isn't exactly software, psychoactive substances. So, for the purposes of this talk, a psychoactive substance is any substance that influences the brain or nervous system and thus behavior, mood, perception, and thoughts. So that's pretty broad, but things like alcohol or caffeine would be common examples. Now, these can be broadly divided into two categories: those commonly prescribed for medical use, such as antidepressants or anti-anxiety medications, and then also those more commonly used recreationally, such as alcohol or cannabis. Now, of course, in practice, these categories are not binary. There are a lot of substances used for both, take like stimulants or cannabis, but it's a useful initial sort of division. Okay. So why am I talking about psychoactive substances and software? Well, there's a connection between psychoactive substance use and programming in the popular zeitgeist. From people talking about programming while using drugs online, to people comparing programming to using drugs, to Steve Jobs saying that taking LSD was a profound experience, one of the most important things in my life, to exposés about microdosing psychedelics, and to, of course, memes like this fairly well-known one about the Balmer Peak. All of these together are anecdotal evidence connecting programming and substance use. Okay, all of this is great, but why should we study it in this more academic context? Why should we talk about it here at ICSE? So I'm going to do a little bit of a case study into cannabis in particular, because it may be that for many software engineering and programming jobs, substance use can conflict with company anti-drug policies. So let's look at cannabis in particular. Here is an anti-drug policy from Cisco that states that employees are not permitted to use or be under the influence of drugs during working hours or while using company property, even when they're working remotely. And this policy explicitly includes cannabis. At the same time, a previous study that I worked on found that cannabis use is common in software engineering, as well as about a third of programmers had taken a drug test for a programming-related job. And this conflict can even sometimes lead to hiring shortages. Yeah. Yeah. So the situation is that psychoactive substances are common in software, but not really understood how they interact with all different levels of software development. And in the talk today, I present results from interviews with 26 professional programmers who use psychoactive substances while working professionally. The goal of this work is to acquire a foundational understanding of the experiences of psychoactive substance users who are also software developers, to clarify the landscape and provide actionable insights for decision makers in charge of company drug policies or the like. So having covered our motivation, I'm now going to talk a little bit more about our methodology and then the findings of how psychoactive substance use interacts with developers at the individual, team, and organizational level. So we conducted and analyzed semi-structured interviews with psychoactive using programmers. Now, more details are definitely in the paper, and we also have our full cold book is available online. I won't have the time, though, to get into it too much right now. But I do want to talk a little bit about who we talked to. We recruited from substance-specific subreddits and posters. Participants ranged in age from between 20 and 44, and they were primarily based in the US, though we did have experiences from 8 countries represented in our sample. Participants had a wide range of professional programming experiences and worked at a mix of industries and company types. So we had some in fintech, some more in the medical side, a couple of government contractors, like small startups to larger, so a pretty big range. The most common substances used by developers in our sample were prescription stimulants, cannabis, alcohol, SSRIs, and psychedelics. Our interviews were semi-structured around 5 research questions that were derived from a preliminary analysis of an existing data set. Now, there's definitely more detail about that study and the questions in the paper. Definitely check it out. But in this talk, I'm going to be organizing the results around 3 different levels of software engineering: the individual developer, the software team, and the organization. But also, unfortunately, I don't have time to talk about the software team. So I'm going to focus on the first and the last one, but there's a lot of good stuff in the middle too. So talk to me about it after the talk. Okay, so starting with the individual developer. Why do programmers use psychoactive substances while programming? Well, there's two kind of broad reasons that people talked about. The first is taking substances to improve mental health. Many developers we talked to use substances such as SSRIs to help with anxiety or depression, or use prescription stimulants to help with things like ADHD. The impact of medicinal substances on programming was broadly universally positive, with some caveats for things like support for switching medications or the like, including by one developer here who found using stimulants life-changing in their software work. The other main reason people use psychoactive substances during programming was programming enhancement. Programmers cited using various substances to improve software productivity, creativity, and development enjoyment. As stated by one participant, he views psychoactive substances in software as similar to performance enhancement drugs in sports, though potentially in a bit more of a positive light. Now, however, one thing we noticed, though, is that regardless of the reason a participant uses psychoactive substances, participants tend to talk about self-regulating which substances they use and when they use them by different software tasks. To illustrate this, on the screen, I have a small set of programming tasks or work goals. Participants would use different substances for different tasks. For example, participants talked about using alcohol commonly to help with work enjoyment and debugging. That's another thing. We had a lot of people talk about alcohol cultures at startups, both in a negative and a positive light, and how that might be treated differently to other substances on this list. Yeah. Also, while cannabis and other psychedelics would be used for more open-ended tasks such as brainstorming or creativity, they were not really used for things like debugging or productivity, more on like the work-life balance side of things. And also, stimulants were generally seen to be helping with basically all software tasks other than creativity, with a specific emphasis on debugging. A lot of people called out debugging specifically as a task helped by stimulants. And mixing a little with the social level, participants indicate they were less likely to use psychoactive substances when collaborating with coworkers. Okay, so it looks like developers self-regulate their substance use by programming tasks. Do developers also self-regulate their substance use while programming, depending on the context or the industry of the code that they are writing? So most of our participants in our sample, and again, it's not like a random sample or anything like that, so I'm not trying to make any empirical claims, but generally people were talking, yes. For example, this participant was talking about if they were programming anything that covered risk or liability, they wouldn't use specific substances as they were worried if someone got hurt. However, this was not universal. One participant expressed the opinion that coding can't really hurt anyone, and so there was no harm in using psychoactive substances. Now, this was definitely an outlier, but I think it's important to share the range of opinions expressed by our participants. Okay, so a summary of the individual level. Programmers use psychoactive substances both for medicinal and programming enhancement reasons. Most developers that we talked to also reported choosing when to use certain substances by the programming task or context. Okay, so I said I wouldn't be able to do the summary for the team level, and I won't. So you can all check out the paper, which has some really cool stuff about like productivity culture, conscientiousness, stigma, all of that. Definitely check it out. Okay, sweet. Thanks. Okay, so moving on to impacts on the organizational level. In this talk, I'm going to focus on participants' views on how drug policies may impact software hiring and retention. The paper contains more detail on participants' experiences with existing drug policies and software more generally, but we'll focus on the hiring and retention right now. So, can anti-drug policies in software impact hiring and retention for psychoactive substance-using programmers? So, there are some reasons why it may hurt. For example, most of our participants indicated that an anti-drug policy would or had in the past influenced their decision to work at a company. Why? So one was that it demonstrates a lack of trust. This is a common theme that we saw. For example, this participant said that it would be a huge deal breaker. They would not be comfortable working somewhere where they were going to have that little trust in me. A second theme that we observed is that it might indicate that there's mismatched values between the developer and the company, that the company might be old-fashioned or out of touch, a situation which might make some programmers reconsider working at a company. Now, while even the existence of a policy may hurt hiring, restrictive policies may do so more. So especially those that involve random testing. Now, random testing, from all that I can find, is pretty rare in software engineering, though we did have one participant in our sample who was at a company that did employ some level of random testing, but there were multiple people who expressed that if that did exist, that would be a big no. Basically, I can get around the on-hire test, but I wouldn't want to deal with it all the time. So why might drug policies not impact hiring retention? So while most people said it would, we did have 10 participants who said it wouldn't. And why wouldn't they? Well, one indicated that they might change their substance use to adhere to the policy. This was said by one participant who basically said if it was a job that they were particularly excited for, they would quit cannabis because they like programming more than smoking. Incidentally, the company on the screen does not typically drug test employees, but this was the one person that said that. For everyone else, for the other 9 participants who said that a policy would not impact hiring for them, they said so either because they view the drug policies as ineffectual, or they plan to continue to keep their substance use private, so would not be impacted. So, as this participant put it, honestly, like, is a company in Nottingham going to come drug test me in the United States? No, totally ineffective. And this was a general thing that was especially with remote work and those sort of considerations. It was almost viewed as like security theater in a way, like the policy's on the books, but no one's going to care here. So with that all in mind, what do psychoactive substance using programmers in our sample want to see change about drug policies and cultures in software? Oops, how do I go back? There we go. So here's a few of the things that people brought up. First of all, participants think that company policy should focus more on behavior rather than the substance use itself. As noted by one interviewee, some people behave inappropriately at work even if they're sober, while others work better on substances, so behavior-focused policies would be preferred. Another one is increased consistency. So sometimes substances policies and then what actually happens in practice are mismatched, or the policy is ambiguous in a way that isn't particularly helpful. Third, there was a general desire for decreased stigma and increased visibility of psychoactive substances in software workplaces, especially those relating to mental health. And there were even 3 participants who expressed the opinion that they would like institutional support for psychoactive substance use in software. So to summarize the company level, current drug policies in software are viewed as inconsistent, not explicit, ineffective, or all of the above. Most of our participants indicated that a drug policy has or could impact their decision to work at a software job, while others cited policy ineffectiveness or the intention to keep their drug use secret, rather than a desire for or agreement with the policy. Participants proposed various changes to software drug policies or culture, such as decreasing stigma regarding substance use, or loosening and clarifying current policies. So, in conclusion, we ran interviews with 26 programmers who use psychoactive substances during their professional work. And we found that this use can permeate all different levels of the development process, from individual usage to the team level, including substances being visible in software workplaces to varying degrees, and increased associated use with productivity culture and work from home, to the organizational policy level, where we found that anti-drug policies in software are viewed as unclear, ineffective, and may have negative effects on hiring or retention. That is everything. Our replication materials are available on the website. Thank you for being here.
And now you can see why it was my privilege. Fantastic. We have time for like one question. I saw this one come up first. If we have time, we'll get others. If not, please find Madeline. She's fantastic. She'd be happy to engage with you on your questions.
And also Kaya has a cool poster.
And Kaya has a cool poster. Same work.
Hi, congratulations. We were just chatting before. One thing I would like to ask, it's sort of a threat of because this is their perception, for instance, debugging and stuff. But what do you think? Because well, in the case of prescription drugs, which is important for focusing for those who have ADHD and stuff like that, but for other psychoactive substances like cannabis and well, LSD, microdosing, whatever, their perception could be a fantasy of the reality. So how do you think that it could be? Well, first of all, congratulations for this, for being courageous, for doing such a work, which is very taboo, and it's, well, thumbs up for all of it.
Thank you. And yes, I think that's a really big question. That's actually what drove me to this research to start with, is I heard things that some of my friends and peers had said, and I wanted to find the research, like what were the actual effects, and there just really wasn't anything. So to that effect, I'm actually working on a first step on that, and I hope other people do this as well. On the background right now, I'm running a study where we're comparing cannabis use on programming versus not. We've had about 50 people come in for about 3 hours each, one time high, one not, to compare programming versus not. I don't have any results yet. I'm so sorry, but I do have pre-registered hypotheses, so you can come talk to me after that. But I do agree. I think that it's a good direction for research to go, and it's one that I'm hoping to work. Yeah, we could also talk to me about that. That was fun. It was like a 5-month process. We talked to the IRB's IRB. It was fun. Yeah.
Fantastic. Yeah. Let's give our speaker one more round of applause.
Thank you.
Hi, I'm Li Kangying. I'm a PhD student at University of California, Davis. I'm very happy today to be here, present our paper on self-governance and episodic changes in Apache incubated projects and empirical study. So let's get started. So there are some risks in open source software. A very, I would say, well-known incident just happened last year, the Apache Log4j vulnerability. The Log4j is broadly used in a variety of customer and enterprise services and websites. It's just to log security and performance information. And this vulnerability is mainly due to the unsustainable development of the project. The Log4j project. The Log4j project is merely maintained by a few set of people. I think no more than 5 active developers. And I found this on the right, the figure on the right is very interesting to show the stage that we are in now. This is on the top, all the modern digital infrastructure, and we have the Log4j underlying project underlying the whole infrastructure. So this is not helpful. This is not very safe and not secure. So such tragedy of commons can be avoided, stated by the theory of governing the commons. Some of you may know that the OSS project is one type of the commons. It's the public commons. And Illinois Ostrom, who was awarded the Nobel Prize in 2009, recognized this tragedy of the commons is not necessary outcome. Commons can be sustainable with proper governance. And I showed the overgrazed landscape in Afghanistan to illustrate this. So in short, OSS needs governance. And this is our observation of a real-world example on self-governance. In December 2018, the Apache project OpenWhisk was experiencing some hard time. Basically, the activity drops down drastically. And once developer noticed this issue and stand out and say, our release process is being impeded by a lack of engagement from eligible voters on the IPMC mailing list. Another developer follow up in the email thread. I will reflect this in the quarterly report. The IPMC is aware of the issue and is currently doing something about that. After the discussion, the number of developers grew back to the normal level, and later the project successfully graduated from the Apache Incubator project. So if we look at this at a higher resolution, OSS project development can change drastically. I use the blue color to indicate the normal or regular development of the project, and the red color indicate the change interval. During the change interval, the project can change drastically. So our hypothesis is that the governance discussion can lead to change interval in social technical structure and vice versa. Our first RQ is, can we measure the change interval in the sense of social technical structure of the project? And then we ask, can we identify discussions that are related to governance? And then for the RQ2, we ask, is there significant difference evident in governance-related discussion associated with change interval? And how do they differ between sustainable projects and unsustainable projects? And in the last research thrust, we ask, what are the two-way association between episodic change direction? So if they change, is increasing change or decreasing change in some of the social technical variables can be related to the sentiment in the institutional discussions. So our data comes from the ASF, Apache Software Foundation Incubator, because they have the publicly available commits and email records. They have external evaluation of project sustainability. So all of our projects are labeled by sustainable or unsustainable. And they host a large enough open source software for us to study. In our dataset, we have 205 graduated projects and 57 retired projects. And we use the method, the network formalism for social technical systems. Basically, we build social network based on the email data. If one developer sends another developer an email, they will form an edge. And we construct the technical networks as well. If two developers commit to the same source file, they will share some technical collaboration relationship so that they will form an edge as well. And then we measure the governance in a form of institutional statement. The institutional statement, IS, is a shared linguistic constraint that prescribes, permits, or advises actions or outcomes for actors. Actors here are the OSS developers. The IS is at sentence level, and it includes regulations, rules, and norms. I list 3 examples of the institutional statement, but I will only name one. Please remember that the final release is dependent on the vote on the IPMC and mailing list. This is the sentence level institutional statement. So our Argue 1, we found that the institutional statement exists and can be automatically identified. We manually annotate 300 plus email threads, and then we use those thread email data to fine-tune a BERT-based sequential sentence classification model, which results in accuracy more than 90%. On the right, I show the number of institutional statements per month for both graduated, which means sustainable projects, and retired projects. We can see that there are significantly more institutional statements in sustainable projects rather than unsustainable projects. And for the second, we measure the institutional change intervals, and we can automatically capture that. This RQ1 is more like a exploratory data analysis. So we just plot the length of the change interval for both graduated project and retired project, and also numbers of them. Basically, we found that there are more and longer change intervals in graduated, which means sustainable, than retired projects. One possible reason for this is that the institutional discussion often trigger change intervals in the project social technical structure. And RQ2, this is a more complex, but I will explain in detail. So on the x-axis, we have the pre-change interval, so the time that before the change interval, and we have the second box plot. Second box, we have the within change interval, and then we have the period right after the change interval. And then we have 2 measures. The first one is the responsiveness index, which basically is the number of emails the delay in time, which we measure in days, they reply to an email. And the second one is the engagement index, which is the number of emails they engage in. And as you can see, we have 3 kinds of different roles. The first one is a committer, the second one is a contributor, and the third one is a mentor. ASF have a very special role as mentor. They give advice to the project, help them to be sustainable. And the contributors are the ones that do not contribute any code, and committer, which by its name, commits code. And what we found is during the change interval, mentors and contributors have a significantly faster response rate. Committer, contributor, and mentors reply to fewer emails during change interval, indicating that the mentors are more focused on certain email thread during the change interval. And I have a big table here, but I will explain in detail here. We have 10 social technical measures. For the network measure, we have clustering coefficient, we have graph density, we have number of nodes, so on and so forth. And then we measure if there is an increasing change interval in one of the social technical feature, will there be more likely to have a positive discussion in this institutional statement. And we can measure this in a reverse way. If there is a decreasing trend, how likely that we will have the positive discussion. And we can ask this to in another reverse way. That is, if we have a positive institutional discussion, how likely are we going to have a positive or increase in certain features of the social technical? We aggregate the above table into the 4 squares. The first one is first 2 is for the graduated projects. The later 2 are for the retired projects. And this indicates that if there is an increasing trend for the change interval, the likelihood for having a positive discussion in the institutional related discussion. In the findings, we found that the positive related discussion are more likely to be followed by an episodic change, while the sustainable projects are more likely to have positive discussions after an increased change interval than retired projects. And we have some takeaways for practitioners. We found that the self-governed institutions, norms, rules, and regulations in OSS project can generate, moderate, and direct actions, achieving feedbacks between effective self-governance and sustainability. And we advise that OSS developers should be encouraged and even brought into project institutional discussions. And we'll also show that there are certain resistance during the change interval. The productivity drops down and there are lower response rate, so on and so forth. So perhaps project can benefit from timing the change interval to occur during periods of low cross-team interaction and collaborations. And that's all I want to share today. Thank you very much. Any question?
So much for the enlightening presentation. Any questions from the audience? We have time for one. We're a little behind schedule, but if we have any questions, we'll entertain them at this time. No questions at the moment. Okay, good, so we can get back on track. Although I do have one clarifying questions around like sorry, look, I'm like, get on track. Sorry about that. But like one clarifying question is like 30 seconds. We can get the next presentation set up though. So you spoke about committers, contributors, and mentors. So just to clarify, mentors are not contributors or members of the project. They're from the incubator, or what is the distinction there?
Sure. The mentors are assigned by the ASF. They require at least 3 mentors for each incubator project. So they are some kind of experts in the field. Yes.
Machine learning is everywhere. I think everyone who checked the program noticed that. Everyone who checked their phone or their car noticed that. So it's just everywhere. But still, there are consistent reports over the last years that only a fraction of actual data science efforts make it to production. So we only see a fraction of what is actually developed. And this has given fuel to a lot of research. Like, we've seen so many technical papers on those topics, and they're so important. They do such a great benefit. But still, what we notice is there's only little work on socio-technical aspects. Although this is a multi-team project, right? It's people building it. And also, a lot of practitioners report that socio-technical, non-technical challenges are actually the ones that they struggle the most with. And there have been few papers on this, and I want to highlight one, which is from Nadia Nahar, and others. It is an amazing interview study where they focus on find challenges related to communication, missing documentation, non-valued engineering, and a lack of processes. Still, we believe that there is a gap, and we identified that gap, and it's a management and leadership perspective. And we also found that there are so many meetups and talks where practitioners share their experience with each other. They discuss it without us asking questions. So it's in a way what comes up from the communities. So we wanted to have a research question focused around that. And we asked, what do experts and technical leaders report and discuss in regard to machine learning products, socio-technical challenges in machine learning products? All right, and for this, we needed a community that fulfills a lot of standards, and we found one. It's the MLOps community, and they were founded in 2020, have more than 15,000 members in their Slack community challenge, so they're actually a bit famous, and they have more than 250 hour-long recordings of videos that can be analyzed and contain a lot of valuable information. Interestingly, the notion is mainly about pipelines, but still they focus on the whole development process, which is really nice because we can have way more insights than just technical aspects on pipelines. So yeah, and they mostly feature technical and non-technical leaders, and often people who have multidisciplinary backgrounds, people who have software engineering and data science skills, which allows us to have a very holistic view on the whole process. But we have to analyze a lot of videos. And that was a lot of work, and we developed a two-phase qualitative research design where we had a filtering process involved and did the main coding and theme development using reflexive thematic analysis, which is a method that is widely used in psychology from Brown and Clark. I guess most people will have heard of it. It's a 6-step process, and it is very flexible, which makes it ideal because we were not able to kind of card sort things because we didn't have questions, so we had to get over the videos and find common structures in the data that we have no influence on, except ourselves. And we have developed 7 themes, which we then structured into anti-patterns, causes, and recommendations, because we believe this is a really meaningful way of communicating those informations. Yes. Information means results, and you can imagine if you have 73 videos, it's really hard to get that results into a 10-page paper. It's even harder to get it in a 10-minute talk. So bear with me, I'm going to give you an overview, and I want you to show how the paper is structured and how each of the themes look like. So we have 3 areas in which we group the themes. One is organizational silos. It's something we kind of know from the DevOps paradigm. Then it's communication on an organizational level. I'm going to talk about that in a second. And it's leadership vacuum on management level. And I'm going to introduce all themes and then go into depth for some. So we have in the organizational siloing, we have model to production integration, meaning one team developing a model, one team has to deploy it or integrate it into a product, a lot of tension. And then we have data to producer to consumer integration, which is also affected by siloing effects. Okay, more interestingly, communication on the organization level. So here we're not talking about communication between individuals, although this is a challenge. It's not in this area. This means communication between either teams or groups of status groups or profession groups. Yeah, when we have redundant development and management versus data science. And I want to briefly talk about redundant development because it's one of the definitely new insights that we gained. Redundant development occurs when you have 2 teams who don't have a use case, so they're not related to each other in the sense that they depend on a handover of software or model or data, but they do have a meta connection where they either use the same data to build something similar or they use the same methods, so they have somehow something in common, which does not require them to interact with each other. And what happens is that they develop features for their machine learning models, which is basically an engineering task on the inputs. Not sure how familiar everyone is, but everyone is developing kind of the same, and they're not sharing it, they're not reusing it, which gives us double the engineering effort. Same appears for machine learning infrastructure and tooling. So each team develops their own tools or deploys their own tool, uses their own tools, and does not rely on the organizational knowledge that's actually there in the organization. And finally, maybe the kind of hyper level of all those 3, it's shadow IT, meaning that you do have a central infrastructure provider, but teams do not use it. They just deploy their own stuff, and this becomes ungovernable and maybe even a security risk. Okay, and I added some of the quotes, and I shortened them. They're very long, they're very amazing. You should check out some on the paper because I think it's worth it. And we found causes here, and it's mainly the missing intersection between the teams, but also a missing trust, even if the things are available. Like if the feature is available to other teams, they don't trust the data that the team is producing because there's no documentation. Okay, so we already continue with the leadership VQM, and here we found generative 3 themes: headless chicken hiring, resume-driven development, and hype-driven product creation. And notably, this was the thickest theme, right? This is the theme where we found in most papers, in most videos, people speaking about. Okay, and I do want to talk about the hiring thing, because it's really nice. And it's also something that is definitely under research currently. And we have a hiring process, and what turns out is we have the wrong staff for our problem. So you have a data scientist, but they have to do an engineering task. That's really bad. Or you have the other way around. You have a data scientist and you don't have a product for them. And that could happen, like, let's say you hire a data scientist for an initial project because you think, oh, that's cool, I want to do that. And after 2 weeks, it's done because it was way easier than you expected. And then that person is employed, but doesn't have a proper project, which is very challenging also on the individual level. Causes. We found that especially unclear roles and titles. I love that quote. You should have the full quote, but it's too much for the slide. And that speaker actually said, oh, and we're going to see MLOps engineers soon. And by that time, when we analyzed it, we were checking portals, and yeah, it was true. There were MLOps engineers, and I think right now it's current common job description. Yeah, but he anticipated this, and this is challenging and amplified, especially by hiring people who don't really know what the tasks are that have to be solved within the organization. And finally, everyone knows that we do have a skill shortage, especially for people who have both skills, software engineering and data science. So. Okay, let's wrap it up. That's the overview again. I really encourage you to read the paper if you're interested in the recommendations, because we were not able to put them in the presentation. But I do also want to give you some material on the way when you read the paper. What can you expect? So let's summarize our contribution. What's in there? And it's threefold. The first is what we just talked about, it's insights. Some new ones, and some which validate existing findings. And that leads us to a second contribution, namely a methodological contribution. Because by validating things that we already know and that were found in interview studies, we show that this approach on analyzing practitioner communities can actually be a valuable source for qualitative data, and especially in an area like ours, where participants are hard to recruit. Like, we wouldn't have been able to do a study with interviews with 73 people in such high positions in so many different companies. So this is a really valuable source for new methodological insights. And finally, we believe that the structure we provide also not only targets academics, but enables the transfer to industry. And when we wrote that in the paper, we were like, yeah, I really believe that. But still, when the response from the communities came, we were so overwhelmed, because finally, when we published the preprint, so many people in the community, but also outside of the community, started to share the paper, say how much they agree with it, how much they identify with it, and what a valuable resource it is for newcomers, but also people who work in the field. And with this, I want to conclude the talk. We also have a poster with a bit more easy to digest insights, and you're invited to read the paper and talk to me. So.
Fantastic. I can borrow your mic just for 2 seconds. Fantastic. Any questions from the audience on this? We actually have time this time. So are there any questions from the audience on this presentation? I will begin and or conclude with a question. So it's really interesting that you were able to get this corpus of data, the video data in particular. Kind of maybe 2 questions. The first question was, were you able to get any deeper insights into the demographics of the people that were in your data set, or was it mostly just you were aware that they were leaders and they were, like you said, technical, non-technical? Were you able to get like roles or any other demographics beyond that?
Yeah, so we did research each person. Some of them were introduced with their job titles and the company they were working in, some were not. We explicitly abstained from having any other demographics that we cannot judge, like gender or any other thing, because it's not possible to get that from the internet. You need to talk to the people, and we did not do that. But we have roles and titles. We kind of started to structure them into management, CEO, CTO positions, and then leader positions like head of ML, head of AI, principal investigator in machine learning. So there were a lot of different roles and titles, and we kind of tried to group them into that management level and then leadership level, which is still above a normal team employee.
And so kind of follow up to that, were there any efforts or any speculation you can provide regarding any distinctions between those roles with respect to some of your findings, or was it that enough of it generalized where there weren't really, particularly around the non-technical and technical roles?
Yeah, we kind of, at the beginning, we also wanted to have that distinction in whether it's a software engineering person or it's a data scientist person, but also it's not that easy distinguishable because you would need to ask the people directly where they come from and what they do.
Okay, so it wasn't always obvious.
It was too high level of the job descriptions that we could not judge that. But
Fair enough.
I see that it's a really interesting information.
And I think your findings kind of suggested also, right, like the roles and titles sometimes mean less than what they actually are doing, or maybe you're not fully descriptive of what they're doing. I actually had a conversation with someone about something similar, like AI engineer and machine learning engineer, like, you know, what's the difference and what, you know, is there a difference and does that mean this and that? So that's great. Thank you so much. Any other questions before we move on to the next talk? Super. Let's thank our speaker again.
Hi, everyone. It's a great pleasure to be here to present to you. And my name is Patricia, as Brittany already introduced me. And I'm an assistant professor at the Federal University of Mato Grosso do Sul in Brazil. And I'm presenting the paper Moving On from the Software Engineer's Gambit, an approach to support the defense of software effort estimates, which is co-authored by Professors Igor Steinmacher, Bruno Gadelha, and Professor Tayana Conche, which is here, was my PhD advisor. And, well, I want to start this talk inviting you to think or to imagine how software practitioners actually estimate a task in their daily practices, right? Which kind of factors are they probably thinking of to get to a good estimate? You can give me answers such as, well, they're probably thinking and trying to understand the task characteristics. What are other past similar tasks to which they can compare the current one? Is there any historical data available, and what does this data tell us? What are the technologies associated with the task, and what's our technical experience with it? And that's very natural to think of, because this is supposed to lead us to technically good estimates. And by technically good, I mean estimates which raise the accuracy of results when we look for actual values. And, well, unfortunately, these software practitioners have to face the hard fact that their technically good estimates are sometimes rejected by other stakeholders. And they might do that because they think of things like, well, these guys are slacking, or these estimates collide with our business goals, or maybe we can get these people to be more productive than these estimates suggest. This ends up creating a lot of pressure over estimates in our teams and in our organizations, leading individual estimators to change their technically good estimates created with our technically good methods, considering those technical factors. And this creates, of course, a lot of time pressure over them. They have to work with tight deadlines. And we have plenty of research linking these things to technical debt and software quality issues. And to explain and to make an analogy right now with chess, of course, because of the title, Queen, the Software Engineer's Gambit, is of course related to the Queen's Gambit, which you might know from the Netflix TV series, right? And what's a gambit in chess? It's actually a chest opening in which one of the players makes a material sacrifice to gain some sort of compensation in the hope of giving checkmate in the end, of course. And we are actually doing something similar. We are sacrificing the quality of our products, the quality of life of team members, because they have to work overtime due to the time pressure created so far. And, well, chess players abandon bad gambits when they don't get enough compensation from them for the material sacrifice, of course. And is there enough compensation for the sacrifices we make for our software engineers' gambit? And if we believe there is not, then what do we do? Actually, we have pretty good software engineers from the past saying that, well, we can defend, or we should defend, our software estimates. And our proposal here is to follow on this idea. Steve McConnell has also talked about defending estimates, and he gave a concrete idea on how to do so. He said, well, we need to become better negotiators. We should look for two negotiation methods, like principled negotiation. We did that. We actually expanded on idea and looked for other negotiation methods. And we went after empirical evidence of the effectiveness of doing so. Well, we created with this an artifact which we call a set of defense lenses. They are represented in yellow and green in this figure, and they are anchored on the principles and steps of the negotiation methods. They look like this. I'm not going in the details. You can find them in the paper and supplementary material, but they aim in changing the mindset of developers and estimators when they are facing pressure over their estimates. We also created a supporting artifact, which is a digital simulation supposed to present the lenses and their ideas adapted to the estimation context. The digital simulation has a set of pressure scenarios inspired in real-life scenarios. Each scenario is associated with a set of alternatives of actions, some of which represent yielding to pressure, which is what we don't want estimators to do, and some of which are related to defending estimates, acting towards that. And we use these actions to introduce and explain the lenses and how they can be used in real life. We evaluated these lenses with software practitioners from the industry. We had actually 32 people participating, and we aimed in answering these two questions. Does the participation in the digital simulation increase software practitioners' intentions to defend their estimates? And what is the perceived usefulness of the lenses from the perspective of these participants? We divided them in one experimental and control group, and they had to answer a pre- and post-test questionnaire before and after the intervention. In the pre-questionnaire, we had questions about demographics, but also about the theory of planned behavior, which we used to assess the behavior or the intentions to perform the behavior of defending the estimates. We also had these questions on the post-test questionnaire. In the post-test questionnaire, we also had questions about pressure for the control group, what pressure scenarios they have lived in the past, what was the impact, because we expected that to also maybe increase intentions of defending the estimates. And it will be an easier intervention than having to study lenses and participate in the digital simulation. It will be interesting also if it worked. And in the post-test questionnaire, we also asked about the lenses' perceived usefulness for the people in the experimental group. And before going to the results, let's understand a bit more about the theory of planned behavior as I used it. Well, this theory says that when you want to assess a behavior such as defending estimates instead of yielding to pressure, you have to look for intentions also, look to intentions actually, because higher intention is associated with the execution of the behavior, right? And it also says that intentions has three antecedents, which are how favorably we see the behavior, is it good or bad to perform it, which we call the attitude, how we perceive other relevant people for that behavior, how they think about it. Do they consider it good, bad? Do they perform it? That's what we call subjective norms. And also, how we perceive the behavior to be easy or hard to perform, which we call perceived behavioral control, right? And when we looked for the between groups comparison for research question 1, and we were, of course, hypothesizing that the experimental group would exhibit higher scores compared with the control group, we actually saw that that was not actually the case. We ran a more traditional null hypothesis testing, but we also ran a Bayesian hypothesis testing. I'm presenting the results of the Bayesian testing only. And we have moderate strength evidence that, well, actually, no, didn't increase. Null hypothesis is just as plausible as the research hypothesis. But when we looked for the within-group analysis, considering the experimental group, what we saw is that actually they had an increase in intentions of performing the behavior, and very interesting, they actually had also an increase in the subjective norms. So they considered that important people for this kind of behavior, like their bosses, clients, their colleagues from their team members, might actually consider defending estimates a good thing to do. And you have to notice, probably they are pressured by their bosses and their clients. Well, regarding perceived usefulness, which is the research question 2, they said that they considered the lens useful, but that's suspicious, right? Because I was asking them. So we wanted to see which lenses they considered the most useful. And different people chose different lenses, which is also interesting because it shows that the lenses cover a wide range of different scenarios, probably. And collectively, they considered all lenses useful except the choose your battles one, which is about using the pressure when it is in the best interest of the estimator too. A few people chose all the lenses stating that they complement each other, which is also very interesting. And the conclusion is that this research is actually not only about estimation. It is about creating paths to get to higher quality software, including paths which are more managerial. When we talk about estimation, we're actually talking about management in sort of a way. And it's also about how being technically good is necessary but not enough. We have to deal and create mechanisms to deal with the behavioral side of software engineering, with the behavior of people which are not accepting, in this case, are technically good estimates. We need to demonstrate that such estimates are in the best interest of everybody here. And, well, that's it. Thank you. You can reach us in this email or in this Twitter. Thank you.
Fantastic. Thank you so much. I was just reminded that I lied again, so I'm just going to apologize for that and try not to lie anymore this session for all this time. Any questions from the audience on this presentation? Please.
I would like to ask, how was the experience of the developers? Since usually good estimators have more experience in time management, and so I was curious about that. So they are able to defend with more precision, they game it with.
That's a great question. Thanks, Lavinia. And well, we have in the experiment, we have people with different range of experiences. It's very interesting that in the control group, actually, people were more experienced. And they also had already, when we ran an analysis of the differences of defending estimates in the pre-test also, there was not, they already had higher scores for defending estimates. Maybe because of that, they were more experienced already. So.
Any other questions from the audience? I have one quick kind of question for you. So like the idea here, right, is in my mind to help bridge a gap, right, between practitioners and how they do their day-to-day and accomplish their tasks and the pressure that comes from the stakeholders who want them to get that done in some way, shape, or form. Were there any insights or any thoughts you have on future work that might look at how effective stakeholders feel that this is in terms of, I'm convinced that you need this time to do this, or I'm convinced that this quality over time sacrifice makes sense? Like, any thoughts on that?
Oh, very good. Well, actually, I didn't think of the other side of the stakeholders. I had only feedback from software developers or people who participated in digital simulation saying, oh my God, I gotta show that to other people in my team because this probably is going to help us.
Right. Yeah, I think that could be really interesting to think about how, if that effectively bridges that sort of gap.
Yeah,
That
but
would
it's
be
a
really
challenge,
exciting.
right? Because
100%.
it will take some time to
And there's
follow
diversity in
up,
that. Yeah, absolutely. Awesome. Thank you so much. Let's thank our speaker one more time.
Hello, everyone. As I was just introduced, I'm Joshua Baylor. I'm here to talk about the iTrace toolkit and the greater iTrace infrastructure that goes along with it. This was work that was done under my advisors, Jonathan Miletic and Benita Sharif. So I will get started. So, like I said, I'm going to go give a quick overview over the iTrace infrastructure and a general recording session before I get into the iTrace toolkit tool. So iTrace is community eye tracking infrastructure that's aimed at providing researchers with tools to help conduct software engineering studies that involve eye trackers. The iTrace infrastructure itself involves a series of tools and data formats that are aimed to assist the researcher with every part of the process, including data gathering and data analysis. So on the left, I have a small overview of the infrastructure and what a eye tracking session would look like. It starts with a participant or a developer sitting down at a machine that has an eye tracker set up and an IDE that we support running a code space that they will be looking at. The eye tracker sends the raw gaze information to our iTrace core program. The iTrace core program then records that data into our core data output format. Core also shares the information to a plugin we have running on the IDE, which then records information including the line and column that the user was looking at and the file that they were currently looking at. This is output into the plugin data format. These two data files are then put into iTrace Toolkit, which is then used for further post-processing afterwards. So I'll talk about iTrace Toolkit. It is the second step in the iTrace infrastructure pipeline, and it does post-processing analysis and filtration on the data that was gathered during the recording session. It offers researchers three main features, the first being the ability to map the gaze data to actual tokens from the source code so you know what the participant was looking at, the ability to aggregate gazes into fixations, and the ability to query the fixation data to whittle down what you need to look at. So I'm just going to go through each of the three features here. So the first is token mapping. Using the line and column data from the IDE plugin and the source.ml XML format, we're able to map each gaze from the recording session to a character from the source code. We're then able to, at that source code, figure out the context of it and gather the whole unique token, word, or symbol that the character is a part of. Additionally, using standard source.ml tags, we're able to get the syntactic context of the token to know what it means in the code. So to illustrate this, I have a brief little example here. The blue circle on value represents a gaze that the user had during a tracking session. And we have a list of data that we would know about the gaze. The first being the X and Y, which we get from the core data, the line and column, which we get from the plugin data, and then we have the character they looked at, which in this case is you, the whole token, which is the word value, as well as the syntactic context. In this case, the user was looking at the name of a value inside of the expression of return, which itself was in the block of an if statement. The next feature that Toolkit offers is the ability to generate fixations. Eye trackers aren't able to capture the more profound saccade and fixations of how the eye actually moves, and instead gather only instantaneous snapshots, which we call gazes. Fixations are what are used to analyze eye tracking studies, though, so we have to aggregate the gazes into these fixations. Toolkit offers 3 fixation calculation algorithms to do so. It goes through the entire list of gazes in a section and outputs the list of fixations that it determines were part of it. We also offer the ability to customize these algorithms by tweaking their input parameters, as well as being able to run fixations, multiple fixations on the data, so you're able to compare and contrast different algorithms in different settings to better aid your research. The last feature we have is the ability to query and filter your fixation data. As your session gets longer and longer, you're going to get more and more fixations. And a simple 5-minute tracking session can easily have over 1,000 fixation points. And researchers will typically only care about a small subset of that data with certain values or parameters they're looking for. So to aid with that a little bit, Toolkit provides pre-made settings that let you filter your fixations, as well as the ability to just load in a SQL query to run on your database and get your output whatever you need. We offer outputs in many different formats, as you can see there. And that is really it for iTrace Toolkit. But if you are interested in getting involved with conducting an eye tracking study or using Toolkit or any of the other tools I've talked about, we have a technical briefing session tomorrow in room 111. There's 2 sessions before and after lunch. We'd be happy to have you there and just show you how eye tracking sessions usually work.
Superior job. Thank you so much. Any questions from the audience about this presentation or the cool contribution? Because this is pretty cool. I will ask a question then. So I think this is actually really awesome because I am one of the researchers who have been completely intimidated by this technology in terms of both the collection and analysis of the data. So the actual cleaning part that happens, is there risk in the processing of losing any of that data, or is most of it just a matter of organizing it in meaningful ways?
We mostly organize it. The Toolkit outputs all of its data into a standard database, and when we import the data, that gets saved in its own table.
Okay.
And then when we do fixations, that is just a brand new table that links them together so you know what gazes make up what fixations.
Beautiful.
But you can analyze whatever part of it. We just offer built-in filtration for the fixations.
Right. And so I saw you had like file search, token search. When you have the token search, is that like I'm looking for how many times the keyword value was looked at, or kind of how does that work?
We offer the ability to, if you want to look at a specific time, the times a user looked at a specific function.
Right.
We offer the ability to paste in the token they were looking at, and you'll get the fixations where the user looked at it.
So I just got to know one time they looked at it, and then I can search for however many other times they looked at it.
Yes, and then using the syntactical context, you're able to get more abstract concepts, like what times did they look at functions? What times did they look at names in general?
Yeah. Holy crap. Fantastic. Let's give our speaker one more round of applause.
All right, so good afternoon, y'all. My name is Ella, and today I want to talk about some of the challenges myself, my colleagues, and maybe even some of y'all have faced when trying to recruit software engineers for empirical research studies. I also want to detail out how we want to take these challenges and turn them into a meta-research opportunity for the software engineering community as a whole. Has this ever happened to you? You've gotten some rude messages. You may have been ghosted. Maybe your research has been insulted. It kind of sucks, doesn't it? These are real things that I have gotten sent to either myself or my colleagues. And we sometimes want to chalk it up to people just wanting to be rude. But if it's happening more often than not, I think it's important to take a look at ourselves and see if we're approaching things in the right way. And what's the best way to do that? Well, that's through meta-research. Meta-research is important because it enables us to continuously improve our research practices. Software engineering is always improving, so shouldn't we also be doing that? So how do we need to really go about that? I really want to understand recruitment challenges as a whole, while also bringing awareness to things that maybe new researchers may not be aware of, myself included. I did not expect things like this to happen. So our proposed research questions aim to gather more data on what challenges researchers are facing when recruiting software developers. How do these challenges impact the research itself? So things like outliers, but even compounding. When you have so many outliers, we want to call them, what happens to the research? How do they impact researchers on a personal level? Like, how does that make us feel? And then ultimately, what do we do about it? So as part of this paper, we ran a pilot study with 7 of our lab's recent research endeavors and found that many of our shared experiences were about recruitment methods that we found helpful, challenges we faced, and what we felt was successful for the research as a whole. We then took the challenges and classified them into 3 categories: participant recruitment, community engagement, and data poisoning. So with participant recruitment, things like no-shows, maybe we have to cancel because something came up with the study. Maybe a participant had to cancel. Everyone has to live their own lives. Maybe someone didn't fill out the whole survey. What do we do with that? Do we try to use that data? How do we use that when other surveys are maybe fully completed? With community engagement, it can be hard when it's online. We are all anonymous, and it can be hard to express sentiment, to express respect. And you need to understand who you're reaching out to as a whole. Customs and norms within communities, what's accepted and what's not accepted practices. And then data poisoning. Purposeful disruptions, behaviors, belittling the researchers, trying to be funny in extra boxes, like putting down chicken nuggets as your gender, or an anti-trans rant. And what do you do about these hostile or irrelevant responses? So based on the things that we have found, what do we currently recommend? So for participant recruitment, introduce your work plain and concisely. I know that seems very apparent, but you really need to be able to show people like what you are trying to get at without, obviously getting too much into the weeds. You need to identify the researchers and institutions when reaching out to people. And for me, this one that is underlined, explaining why you're approaching this person or community. This one, I think, is one of the really, really biggest ones. It sticks out for me because I've moderated a large regional subreddit for almost 5 years now. And we get so many people like, hey, let me post my survey. And when I have my researcher hat on, I'm like, oh my God, I understand your plight. But then when I take my researcher hat off and put my moderator hat on, these requests have nothing to do with this community. And as a moderator, it's really, really important to understand and curate your community and protect your community, especially in communities for maybe women in STEM, neurodiversity subreddits. As a moderator, it's your job to ensure that your community is not being approached in a way that is not respectful. So taking the time to explain why you're approaching a community, how it will affect your community members, will go a long way as a researcher to provide respect to the people that you want to participate in your research. Additionally, you want to motivate the benefits, clear and concise impacts, explain how you handle anonymized data. That was a big one. What are you doing with your data? How are you going to process it? You want to provide contact information in case anyone has questions. And something else that was really helpful was linking to survey or interview questions when you're reaching out to specifically people like moderators. So hopefully we have some time for questions. I appreciate y'all so much for letting me come up here and talk today, and I'd like to open the floor for any at this time.
Fantastic. I know it wasn't me that did it, but I want to apologize that you've had those experiences. I have never, and let me explain, could never. All right? So you're a champ. Okay, so questions. We have time. I saw one hop up in the back, and I'm going to come right back to you. Yes, ma'am.
They were kind of approaching because we were giving them $50. Still, my students are having hard time recruiting professional programmers. Do you have any those kind of experiences? Because it seemed like most of the examples were around as a researcher, what we already do on IRB, give them all this information, but I didn't see anything like how can we verify that these are real professional programmers and not
Yeah, so that's a great question. I know that has come up in a couple of our labs needs in our what we want to recruit people for. I personally don't have any recommendations for that, but I do believe that is an issue that we do need to address.
Yeah, I was simply going to say that almost everything that you listed as recommendations is IRB or REB requires anyway.
Yes.
So but the one you underlined is the key, because that's not required by the RF. Yeah.
Yeah, so that as part of ROB process that isn't, but that kind of comes from my own personal experiences. Yeah. I'll have someone who had reached out like, hey, you removed my survey, why? well, I don't know who you are. I don't know what this survey is for. To me, it's building that respect with the people that you want to research. You're trying to almost build that personal connection, even though it's hard online too. It's the olive branch is as much as you can hand it to someone.
Thank you.
Uh-oh. Andy's going to ask me a question.
So I'm finding that our IRB at CMU is quite prescriptive about the kind of language and exactly the wording we use when we advertise for our research on public forums like Reddit and Twitter and stuff. But I feel like there maybe, do you have any recommendations for better wording or better wording choices that would reach these people more than the technical jargon that our IRB is forcing us to use?
Yeah, so I've found that I will put the technical jargon within something like an online survey or a consent form, but then really just, I hate to use the word dumb it down, simplify it. And, so if there's particular words for communities that you want to reach out to that may be like neurodiversity subreddits or more marginalized communities, use their colloquial language, like as if you were talking to like, I think it's like it's like if you ran into someone at the coffee shop and they asked you what you do, explain it to them in that sort of way, while also then providing the technical jargon when they accept to participate.
Hi, thank you very much for your presentation. Isha Richardson from Lero in Ireland. And I'm trying to figure out how to phrase the question or what I want to say, but I do a lot of interdisciplinary research, and certainly some of the feedback that we have heard, and I think particularly through other disciplines, is that we as researchers come in, take our pickings and walk away again. Yes. And I suppose one thing is, how can we feedback? I think feedback is very important, but in healthcare in Ireland now, you will not get a grant without involving the patients right from the start. Research design, and it gets over things like, why are we going to this community, how do you phrase your questions, right through. And I think something like that can really make a significant difference. So maybe if we're talking to programmers about something, then involve the programmers right from the start.
Exactly, yes. And touching on, coming and taking data and never bringing it back. That is actually an effort that was sort of tangentially related to this, is that we are wanting to start a community where we can almost share these results. I know with research, it can take a year to get things published, but if there's ways to at least go back to the community and be like, hey, thank you so much for participation. I was here 6 months ago. We have had XYZ found. Thanks again for letting us come into your community. So.
Fantastic. Any other questions? I think our keynote this morning also did a great job of emphasizing the importance of circling back and keeping your participants and users, however you label them, in the loop on what you're doing.
Yeah. Keynote this morning, I was like, oh no, she's going to steal my thunder.
It's appropriate. No, she hyped you up. Yes. Is what happened. Yeah. Any more questions? Fantastic. Well, we are a wrap, ladies and gentlemen. Thank you so much.